we are going to look at the Kolmogorov's forward equations. Let's recall a little bit. We know that the matrix probability TPX, we can rewrite it in terms of TPX00 here, TPX01 up until TPX0n if you have n times of jumping. So from TPX00 up until TPXn0, and here that your last term would be TPXnn. We also know that if you sum all of the summations for all of each of the rows, you are going to get 1. Here also, if you sum all of these rows, you are going to get equals to 1, because the total probability of from one state going to another state or remaining in that particular state will always be equals to 1. So summation, we can rewrite it as summations of j equals to 0 up until n TPXij equals to 1. And from previous video also, we know that hpx plus tij, this one will be equals to mu x plus tij times with h plus with oh. So from here, if we want to find the probability of not transiting, it would be 1, because the total of the probability is 1. Okay, the total of all of this probability equals to 1. If you want to find the probability of not transiting, which is this probability not transiting, it will be 1 minus all of the other probabilities. So it will be 1 minus summations of all of the other probability except for the one that you want. You are not moving from that particular state. So you are going to have hpx plus tii. Okay, and then I also know that hpx plus tij is this one. So using this one, then I'll replace this into mu x plus tij. So same, it will be equals to 1 minus, this one is still j equals to 0, j not equals to I up until n, j equals to 0, j not equals to I up until n. So you are going to have 1 minus mu x plus tij times with h plus with oh, and then factor out h, then I will have 1 minus h times with summations of mu x plus tij. Mu x, summations of mu x plus tij, this one is equals to nu x plus tij. So everything's here becoming this one. So I will have 1 minus h times with nu x plus ti plus with oh. So how does this relate to the KFE? Let's look at what KFE says. KFE is actually the net rate of change, rate of in minusing the rate of going up from one state to another state. So if we are talking about rate, we are finding the differentiations of the probability here, probability of going in and going out. Okay, so for here you are going to have summations of k equals to 0, k not equals to j, and tpxik mu x plus t kj minusing with, because it is the rate of going out, right? So it will be tpxij mu x plus tj. So where you also have 0 pxii, that means that starting it will always be 1, and 0 pxij, it will always be 0. This is given that you cannot maintain in the j state. Okay, and your r is not equals to j. So you are moving from state I to another state. In the matrix form, you can rewrite it as d over dt tpx qx plus t. We have seen this in the previous video. However, we are going to look into a little bit more details of how this one is derived using the CK Chapman-Kolmogorov and also the first principles of derivatives. So we know that t plus hpxij, this one equals to the summations of k equals to 0 up until n tpxik hpx plus t kj. You have to make sure that both here is k. If not, you cannot times the matrix. You have to remember that whatever that we are doing here is in matrix. Okay, so from here, then I would like to take out k equals to j. So when I'm taking out k equals to j, the rest are remaining the same, the summations of everything, and then I'll plus back when k is equals to j. So when I plus back my k equals to j here, so this summations is equal to whatever that I have above. So after that, I'm taking the t plus hpxij minusing tpxij. So I minus tpxij from this side and everything's remain the same. Here also minusing tpxij from this side. So left hand side, right hand side will have the same equations. Now I factor out tpxik and then hpx plus tkj. This one is using whatever that we learned above here. We are using this concept and then we replace it inside here. So replacing it here, I will have this times with tpxik, and then for this part also we'll have tpxij 1 minus hpxjj, this one as mentioned above. Here it will become something like this, 1 minus h nu x plus t I. So for our case here it will be j, and then times with h plus oh, and then minusing the tpxij, and everything remain the same for this side, and then from here I times it inside and I will get this one. This times it inside, I will get tpxij times with nu x plus tj times with h plus with oh, and then minusing this part. So from here you see tpxij here can cancel out with this one, so left over with the rest of the function. So when I have OH functions plus another OH function, it will become another OH function. So this OH plus this OH, here the summations of all of the OH will become this OH. Okay, so tpxik mu x plus h kj here times this one and this one, it will be left as this one, and then this h factor out here, minusing with tpxij nu x plus tj, and then here also have h, so you factor out as well, so you are going to have a bracket here plus with OH functions. Okay, this OH function, as I mentioned, it will be these OH functions, your sum all of these OH function plus with this OH function becoming this another OH functions. These OH functions later on we are going to ignore it because it is very very small. So for here you are going to get h and then bring it to the left hand side, and then you are going to get the summations of tpxik mu x plus tkj minusing the tpxij nu x plus tj. This one is also equals to tpx times with mu x plus t in terms of matrix. If you expand the tpx, the matrix of the tpx as per above, and then you expand the transition intensity matrix also, and then when you expand this times this, you are going to get whatever that we have above here. So this is almost similar. Okay, that's it for the part 1 of Kolmogorov forward equation.